All right, let's look at finding the area of a regular polygon. Somebody asked for some extra help from this. So to begin with, we need to understand some basics about polygons. I've drawn an octagon here. This is really going to apply only to regular polygons, which means all these sides are the same length and all these angles are the same size. First thing to know about regular polygons is mostly they're difficult to draw well. But some things that we can extract from all of them is that they will always have a certain number of sides, and we're going to use the variable n to represent the number of sides that the polygon has. So because this has 8, we call it an octagon, but if we get up to bigger numbers, if it had 26 sides, we would just call it a 26gon. Okay. One of the other characteristics of a regular polygon is how big it is, its size. And that can be given to you in a number of different ways. They could tell you how long each of the sides is. We're going to call that B. We'll show that here in the picture. Each one of these sides is B. The perimeter is all the sides added together. Okay. And we'll call that P in here. So if we added all 8 of these sides that are all length B, that would give us a perimeter. We have a radius, which there is a center of this polygon. We're going to call the radius R. And that goes from the center out to one of the vertices of the regular polygon. So there's a picture of R in this. And then they could also tell us about something that they call the apothem. The apothem goes from the center perpendicular to one of the sides, and we'll call that A. Now, some key relationships that we can get out of what's going on here. We've got some other things that we're going to need to do. The key to finding the area of a regular polygon is to build one triangle inside of this. And the polygon is just multiple identical copies of that triangle put together. And so we can see if we highlight this one in here, the apothem becomes the height of that triangle. The radius is the hypotenuse. And this little piece in here is not the whole base, but it's half of the base. And so since we have a right triangle in there, we can do some trigonometry if we knew any angles. And so we'll mark that angle on the inside. One of the relationships is that that angle, the size of it, is always going to be 360 divided by 2 times the number of sides. Okay, so that will tell us how big that angle is in there. We know, as we kind of stated before, that the perimeter is just going to be n times the side length B, okay, where n is the number of sides that are in there. And if we do n times the area of one of these triangles, that's going to give us the area of the whole polygon. So I'm going to extract from this picture one of these triangles and draw this in here, calling this theta. This whole thing here is the base, this is the radius, this is the apothem. This is a picture that we are going to draw every time that we're trying to find one of these. Okay, so there's the basics of it. Let's start looking at some examples. I split this into 3 types depending on how they tell you about the size of the polygon. So my first one is if you are given the side length or the perimeter. So here's my example. A regular octagon has a perimeter of 48 centimeters what is its area? Well, if the perimeter is 48, then, and it's an octagon, so it has 8 sides, then that means each side is going to be 48 divided by 8, or 6 centimeters on a side. So I'm going to draw the triangle like I did. And if this whole thing is 6 across here, then that means this part of it is just 3. So that's what I know right now. I'm going to write down that the area of this triangle is going to be 1/2 times b times a, and I already know the b is 6. So I have that much that I can fit in there. The angle, remember my theta up here, this angle is going to be 360 divided by 2 times the number of sides. So 2 times 8 is 16, and 360 divided by 16 gives me 22.5 degrees on that angle. So I have a 22.5 degree angle in there. My next step says, now that I've found the theta, that I'm going to use the tangent of that angle. So the tangent of 22.5 is equal to half the base, which is, the whole base was 6. So that's 3 divided by a, and I need to solve for a, and that's going to be 3 divided by the tangent of 22.5. Making sure that I am in degrees, which I already checked on this calculator. I do 3 divided by tangent of 22.5. That gives me about 7.24. That would be centimeters for the apothem. So the area of my triangle is 1/2 times 6 times 7.24. I'll use what was already on my calculator. I'm going to multiply that by 0.5 and times 6, and that gives me an area of 21.73 approximately. But the area of the whole polygon is going to be in the number of sides, which is 8, times this 21.73. So if I just multiply this by 8, I'm going to get an area of about 173.82. This is area now, so that is in square centimeters, and that is my answer to that problem. Type 2, if I am given the radius. So here's my sample problem. The radius of a regular 12-gon is 9 inches. What is the area? Well, I start by drawing my triangle. And the radius is 9 inches, so that's right here. I'm going to write down that my area again of the triangle is 1/2 times b times a. This time I know r. I don't know b or a. I need to find my angle. My angle again is going to be 360 divided by 2 times the number of sides. This had 12 sides, so 2 times 12. So I'm going to do 360 divided by 24, which gives me 15 degrees. So I have in here a 15-degree angle. I need to know the b and the a to do this. So this says, first of all, cosine is adjacent. That's going to be, there's my a. My half of b is right here. So the cosine of 15 degrees is equal to the a, which I don't know, divided by my r, which is 9. So A is going to be 9 times the cosine of 15 degrees, which is approximately, I'm going to leave it as 9 times cosine 15 for now. I also need to find, so that's my A, I also need the B for the formula. So the sine of 15 degrees is half of the B divided by the R, which was 9, and that tells me then that B is going to work out to be 2 times 9 times the sine of 15 degrees. So finding the area of the triangle is going to be 1/2 times B times A. My B, 2 times 9 is 18 sine 15 degrees, times A, which was 9 cosine 15 degrees, and I'll type all that into my calculator. So I've got 1/2 times 18 times the sine of 15 times 9 times the cosine of 15. Make sure I get all those parentheses closed up in there. This gives me 20.25. And that would be right now in square inches, but of course I want the area of the whole polygon, which is going to be the 20.25 times, what I've got, 12 sides, so times 12, which gives me exactly 243 square inches. I don't even need the approximately equal to's on this side one. All right, and then the last one, I'm going to call type 3, is if I am given the apothem. So the apothem of a regular 21 is 18 feet. What is the area? Draw my triangle. What I know this time is that this is 18. This is my radius here. Here is half of my base. I'm going to write that my area of the triangle is 1/2 times the base, B, times the apothem, which I now know is 18. I'm going to find my theta, which is 360 divided by 2 times 21, so 360 divided by 42, probably going to be kind of funny looking number here. Okay, and when I do that, I get about 8.57 degrees. So that's my angle up here, 8.57 degrees. I think that's probably enough decimal places. So the tangent then of 8.57 degrees is equal to half the B divided by the A, which was 18. So the B is going to be 2 times the 18 times the tangent of 8.57 degrees. And the area of my triangle is 1/2 times that B, 2 times 18 is 36, times the tangent of 8.57 degrees, times the A, which was 18 from before. So punching that all into my calculator, get 1/2 times 36 times the tangent of 8.57 times 18, and I get 48.83 approximately. That's the area of the triangle, so the area of the polygon. I had 21 sides, so it's going to be 48.83 times 21. Just keep the number that I had on my calculator and say times 21. And that tells me that it is approximately 1,025.36 square feet based on the units that I had in there. So that's an example of all three ways, depending on the information that they give you. Hopefully that will help you out.